Okay, let's look at this one. Now, in real life, just know a lot of times your coefficient will be a pi because, how can I say this? When you do the math, you want the pi's to cancel out so that your x's are, say, days or months or years or some real life unit. Okay, so in real life, a lot of times your input is time, not an angle. And so you have all this angle-y stuff, I guess, because of course the input to a trig function is an angle, but it needs to all cancel out so that the variable that you care about on your x-axis is not an angle, it is time. Okay, and we'll do some real life story problems so you can get what I'm talking about. All right, again, I like to start with my range, so I like to deal with output first. Okay, output is normally -1 to 1. I have 3, -3 to 3. And then I am shifting it vertical shift. What is it? Det and det is at -5 and 1. Okay. All right. Now this is your new range after the transformation. Okay. And again, what do I know? I know my range. I know my amplitude is the absolute value of 3, which is 3. Okay. And I know my vertical shift, I guess I should make my little loopy bigger. My vertical shift is what? Down -2, so down 2 units on the y. This is all dealing with the y-axis output. All right. Okay, let's deal with the input. Now again, know that cosine looks like a cup. So it goes high, mid, low, mid, high. That's if there's no transformation on it. And this one's not reflected, so we're okay there. It's going to look like a cup. All right. So again, normally the period to do the 5 key points is 2 pi. That's your normal period. There's a transformation on our angle as well, because here's your function, right? And so all of the stuff dealing with input is right here. All right. So we're going to go 0. And we're going to stick the input in between 0 and 2 pi. Okay. All right, now I'm going to solve for x. So first of all, I want to get this chunk. So I'm going to add pi over 4 to everything. So over here, I get pi over 4. These cancel. So I get what? Pi and then an x. Here I need a common denominator. So I'm going to put a 1 under there times 4 to get a common denominator. So I have 8 pi. So I'll come do this over here. You have 8 pi over 4, which you can see that really does equal 2 pi, plus pi over 4. So you get 9 pi over 4. I'm just adding fractions. Now I want to solve for the x, right? Because I want to know what x is. So to get rid of multiplying by pi, I'm going to divide by pi. Now, since I'm dealing with fractions, dividing by pi can get a little dicey. So I'm going to use 1 over pi, because then with my fractions, that just works better. Okay, kind of like when you're dealing with fractions, if you have, say, 3/4 and you're dividing by 2, probably better just to multiply by half, right? Because you're going to have to multiply by the reciprocal anyway. So to cancel the pi, I'm going to use 1 over pi. That's going to be a little cleaner. Now, this is what I was talking about earlier. Do you see how those cancel? And I get 1/4. And then over here, do you see how the pi's cancel? And I get 9/4. So see, this is probably like a unit of time, like 1/4 of a minute, right? And this is what? 2.25 minutes. It's the angle part is gone because when I did the math, it all canceled out. All right, so now we're gonna graph. All right, so this is my start, this is my end, okay? And I do know that it looks like a cup, right? So we know all that stuff. Okay, so I'm gonna come down here to do this. All right, so let's see, what do we have? -5 to 1. So I'm kind of heavy on the, negative side. All right, so -5, 1, 2, 3, 4, 5. So -5 is my low, and my high is what, a +1? So my mid, that's a distance of 6. So I need to go up 3. So 1, 2, 3. Now we talked in class, is your vertical, is your vertical shift your mid? And the answer is yes. Okay. All right. So now what do I need to know? Okay. So 1/4 and 9/4. Now that looks like there's a lot of cuts in there, right? That's 8/4 distance. So that's 8 little tick marks. So I'm not going to have to cut this more. In fact, I'm probably going to have to skip some jumps So I can put these pretty close together. All right. So I am going to do, what do I have? 1/4. Now notice these are not pies. So I'm going to do, 1/4, and then there's 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4. And again, you need consistent units. You can't have one big gap, one little gap, and big, you need to kind of try to measure. If you need a ruler, like during class, I can, like a test or whatever, I can give you a unit, a ruler. So you have nice units here. But on a grid, you want consistent units. Okay. So I think that's everything I need. Okay, so let's think about our typical cosine. It starts with a high. So at my start, this is going to be a high. All right, let's talk about the end. A cosine is a cup. It ends at a high. So where's my 9/4? That's a high. Halfway in the middle is a low. So now again, this is a distance of what? 8/4. So half of 8 is 4. 1, 2, 3, 4. Distance of 4 is going to be a low. The other thing you could do is cut in, right? 1 jump, 2 jump. Did I do that right? Sorry. I can't do this. 1, 2, 3, 4. And you're at the middle. Okay. Now, again, what happens halfway between these two? Another thing, right? And that's a mid. So this was a distance of 4. So if I go in 2, I'm going to get a mid. And if I go in 2, I'm going to get a mid. So do you see how this one's cut in more tick marks than I need? I actually have to skip 2 tick marks to get to the next thing. So when you keep graphing, don't just, you got to remember, I got to jump 2. All right. And again, you don't want this to look like an absolute value. So you want to kind of make your curvies actually before you connect them. Okay, so from here, remember, you're going to skip 2, go to a mid. Skip 2, go to a low. Skip 2, go to a mid. Skip 2, go to a high. Okay, and then on this side, same thing. I'm here, so I'm going to skip 1 jump, 2 jumps to go to a mid. Skip 2 jumps to go to a low. 2 jumps to go to mid, and keep going. All right, so that's how I graph it. All right, now, how do I answer the question? So we have all these nice output questions, right, that we like. What about on the other end? Okay, so let's talk about the angle stuff. Okay, so on the angle end of things, what do we care? Well, we care about the period. Okay, so again, these might be like, 2/4, 3/4, 4/4, which would be like 1, right? 5/4, 6/4, 7/4, 7/4. This would be 8/4. That's like 2. So these might be seconds. Like after 1/4 of a second, it does this. After half a second, after 0.75, after 1, after 1.25, 1.5. This might be a unit of time. Okay, and this might be happening. Oh, I don't know where we get negatives. Maybe temperature, right, in January somewhere in the United States. Okay, so period, there's a couple ways to get it. Probably the easiest is 2 pi divided by the coefficient output of x. Some people call it b, some people call it omega. 2 pi, what's my coefficient? Now notice it has a pi in it, my coefficient of x. So do you see how that cancels? And you're like, oh, my period is 2. There's no, nothing in there. So if these are minutes, every 2 minutes, this cycle repeats, or every 2 hours, it repeats, okay? Now, again, how else could you get it? Well, from the start to the end, 1/4 to 9/4 is 8/4. That also equals 2. So you can get it that way as well. All right, so what else do I care about? The phase shift. All right, so the phase shift, you can just look here. So it's 1/4. So it's to the right 1/4 because it's positive 1/4. The other way to get your phase shift is to set this equal to 0. So you could say, okay, Julie, I'm just going to set it equal 0. I like that method better. So bring that over. To get rid of multiplying, you divide. But again, we're doing fractions, so I would use the reciprocal. I just think that's better. And see how the pi's cancel, you get a 4th. Now, if you truly want to see it, this really should be in factored form. So let's factor it out. So let's see how they both have a pi in common? So I'm going to pull the pi out, okay? So this pi, they both have this pi in common. So I'm going to factor that pi out. So when that pi factors out, this one has an x. When I take this pi out, there's an invisible 1. So when that pi comes out, this has minus 1/4 left. okay? So when you do that, you can see, oh yeah, if I set that to equal to 0, yeah, the phase shift really is a fourth. Like that's really what's happening on the x-axis, okay? All right, so those are kind of the main, these ones over here, right? And then these ones over here, that's what we care about when we're talking about trig functions, okay? All right, as far as sine and cosine goes. All right, hopefully that helps you. If you need more help on this, let me know. Next week we'll try to get better at it, and we'll do some weird ones with a few other things too. But hopefully this gives you a good start.